So today we're going to start with a review of radicals. And that, when I say radicals, I'm talking about specifically square roots and how to simplify square roots. So the question we want to answer today is, how do we simplify square roots? Now, radicals can, the term radicals can apply to various types of roots. We're going to specifically talk about square roots today. Alright, now, a radical is any expression with a square root, a cube root, a fourth root, fifth root, sixth root, seventh root, whatever the root is, that's considered a radical. The radical symbol is what we call the square root symbol, but it's really a radical symbol. Now, in simplifying square roots, it is extremely important for us to kind of know by memory the first 20 perfect squares. Now remember, a perfect square is a number you can take the square root of, and it just gives you a whole number, like the square root of 25 is 5. So let's list those real quick. So we got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Alright, that's the first 10. Now notice, you really don't have to commit these to memory, because how do I get these numbers? 1 squared, 2 squared, 3 squared, 4 squared. Okay, so you should never really have to memorize these, even though it's good to have them memorized. Alright, the next 20 would be starting with 121, 144, 69, 256. That's 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 381, and then
20 squared is 400.
I'm not, 20 squared is 400, yes. 361, thank you. Alright. Okay, 361. Okay, so we've got the first 20 perfect squares listed out. Now, when it comes to simplifying radicals, there's two cases. Case 1 is you're just going to take the square root of the number if it's a perfect square. So, for example, if I had the square root of 36, what's the answer? 6. Now, realistically, it's not just 6. It's positive or negative 6. Very good. And the reason that is, for this context, is because we're dealing with quadratic equations. So how many solutions are there for a quadratic equation? 2 solutions. So we have to use both of the solutions, positive 6 or negative 6. Now, in general, when we take the square root of a number, we just take the positive. We just say 6. But when we're dealing with the context of quadratics, then we have to take the positive and the negative version. You say, why is there a negative version? Because negative 6 times negative 6 is positive 36.
That's right.
Positive 6 times positive 6 is positive 36. So both of those answers count toward the solution to the square root of 36. Alright, now, case 2. Case 2 is when we do not have a perfect square that we're dealing with. So, what are we going to do when there's a non-perfect square? We're going to break the radical down using the largest perfect square, and they left off the word factor. Using the largest perfect square factor. Then, we're going to take the square root of the perfect square factor and leave the leftover under the radical symbol. So, what is an example? What if we have the square root of 48? Now, 48 is not in our list of perfect squares up here. Okay? We'll talk more about it in a minute. So, what we have to do is we have to find a factor of 48 that is a perfect square. So let's write out the factors of 48. Let's do it right here. Factors of 48. Don't worry about 1 and 48, because that's not going to do us anything. 2 and 24. 3 and 16, 4 and 12, 6 and 8.
Oh, 16.
16 is the largest of these factors that is a perfect square. So that's the pair that we're going to use, 3 and 16. So what I'm going to do is break the 48 down into 16 and 3. Notice that 24 is not in our list. Okay? Alright, so 16 is the largest perfect square factor of 48. So I break the 48 down into 16 times 3. Then I take the square root of 16, which is what?
4.
4. So what I do is I generally just mark out the 16 and put the 4 on top, because it's like it's coming out. The square root of 16 is 4, so the 16 goes away, and what's left is 4 on the outside.
16.3.
No, 16 times 3. Okay, so the final answer is 4 root 3. So, I don't want any decimal answers here. Decimal answers are not allowed. We're either going to have a fractional value or something that's left in the form of a square root like this, 4 root 3.
But what is already a number outside? Is it the problem?
Great question. So Paige took us to the next issue, and that is, if there is a coefficient outside the radical, multiply this with any number you take out. So what if I had 3 on the root of 125? So first of all, I got to simplify the root of 125. So what's the largest perfect square factor of 125?
15.
No. 25. So we're going to break it up into 25 times 5. Notice the 3 is still there because it's still part of that expression. Okay, the square root of 25 is what?
It's 5.
5. So I mark out the 25 and I'm going to put a 5 on top. Now, I don't leave it like this. I go ahead and multiply 5 times 3. So 15 on the root of 5 is the final simplification. So notice that in my two examples here, I did not write a decimal. No decimals. I don't want decimals. We want to leave our answers in the form of a radical, if necessary. If it simplifies fully, like the square root of 36, obviously you don't have a there would not be a decimal, okay, even if you put it in the calculator. Alright, so let's do the first 6 of these examples real quick, because none of these examples deal with non-perfect squares. So what's the square root of 49?
So 49 is 7.
Okay. What's the square root of 225?
15.
That was easy. Okay, now it's 2 times the square root of 144.
It's 2 to the square root of 12.
2 times 12 is?
2 times 12 is 24.
24. Notice that my answers do not include a square root symbol.
Hey, you forget the positive and negative sign thing.
I am. Glad you said that. So, notice that we do not include the square root symbol in our answer. When we take the square root of a number that simplifies, there's no more square root. Okay? So we do need plus or minus on all of these. Alright. So, next. Now, you know, I need to make a point here. On these values, are these the solutions of a quadratic equation? No.
No?
So technically, do I need the plus and the minus for these?
No.
Technically I don't, because it's not a quadratic equation that requires 2 solutions. So, but we are going to still do it. We're going to do it because we want to get into the habit of doing it when we're doing quadratic equations. Alright, so number 4, what do we have?
Number 4, we have square root of 4 over 9. It's 2/3.
2/3. Because you're going to take the square root of 4 and the square root of 9, which gives you 2 over 3. No decimals. Leave it as a fraction. Alright, square root of 1 over 81.
What it is?
Good. Square root of 36 over 121.
Over 11.
Okay? That's what I'm saying. Yes. We're going to do it for habit's sake, to create a habit. Okay? But if it's not a quadratic equation, technically you would not need to, because you would be expected to find the principal square root, and that would be the positive. Alright, now, number 7 deals with a value that's not a perfect square. So we have to find the largest perfect square factor of 112.
10.
10's not a factor of 112.
Oh my.
What about
11
11?
might be a factor, but I don't think it is. It's not. But even if it was, 11's not a perfect square. So let's list the factors of 121. 2 and 56. 4 and 28. Let's see, what else? 7
I know, it's
and
16.
16.
It's 16.
Okay. 14 and 8 is another one. Okay, so, of these, this is the pair that has the largest perfect square value. So therefore, this is the pair that we're going to use. So this is going to become the square root of 16 times 7. The square root of 16 is?
4.
4. That leaves us 4 on the root of 7 for our answer, plus minus. Alright, number 8. We want to find the largest perfect square factor of 245. So I like to do it over to the side. So we're going to have, let's see, 2 is not a factor. 3 is not a factor. How do I know 3 is not a factor of this automatically? Can anybody remember the divisibility rules for 3?
Odd, even, and odd.
Alright, you're on to something there. What? It doesn't go into anything here, but here's how I know if it's divisible by 3 this fast. I add up the digits. 2 plus 4 plus 5 is 11. And 11 is not divisible by 3. So guess what? This whole thing's not divisible by 3.
I know this answer, sir.
Alright, so it's not divisible by 2. It's not divisible by 3. Therefore,
It is divisible by 5, though.
it is. It's not divisible by 4. But it is divisible by 5.
So it's 49 times 5. 49 is a perfect square.
Yes, it is. So, if that's the case, we can really stop right here. Because 49 has got to be the largest perfect square factor.
Yeah, you do that, 49 times 5, cross out the 49, put a 7 at the top, and that equals 7 to the root of 5.
Excellent, Paige. Alright, I'm going to pause the video, and you try number 9. Okay, so, 72. Over to the side, we list the factors. 2 and 36, 4 and 18. Now, pause for a second. If we know that 36 is a factor of 72, we can stop right here.
The 36 is a perfect square.
Because 36 is a perfect square. Alright? So, 5 times the root of 36 times 2. Now we can simplify. What's the root of 36?
6.
So that 6 goes on top. I mark out the 36 because it's gone.
Well, 5 times 6.
Now you multiply 5 times 6 is 30 on the root of 2. Don't forget your plus minus. I always forget it myself.
Oh, yeah, we done got a point off that.
So, if you forget your plus minus on the test, am I going to count off for it?
Yeah.
Maybe, maybe not. We'll see. If you can show me you can do the simplification the right way and solve these things the way they're supposed to be solved, and that's the only thing that you don't do, I'm probably not going to take off points. But you should write the plus or minus, it's not necessarily for these, but for the quadratic equations, because you have to have 2 answers. Alright, number 10. We want the factors of 45, and the largest of which is a 9. So, 9 times the root of 9 times 5. The square root of 9 is 3. 3 times 9 is 27 on the root of 5. Plus minus. I always forget that. Alright, number 11. Square root of 250. So, we're going to break this down into the largest perfect square factor of 250. 25 times 10. And you say, wait a second, I thought 10 was a perfect square. It's not in our list, is it?
No, 25
No.
is a perfect
It's a nice round number. We like 10s. Okay? but it's not a perfect square. So the square root of 25 is 5. So plus minus 5 root 10. Now we still have to write the root 10 part here because the 10 did not get simplified. It is still under the root. And number 12. We want the factors of 578. And look, I don't know what those are. I got to work it out. 578 is divisible by 2. 2 and 289. I can stop there. Look. 289 is one of our
Numbers.
perfect squares. So, 3 on the root of 289 times 2. Square root of 289 is 17. 17 times 3 is 51 on the root of 2, plus minus. Alright, let's turn the page.
Okay, what is that?
That's 289.
Oh man, what is this?
289.
X squared minus 64 is 0.
Alright, now, the reason that we did all this is because we're about to start solving quadratic equations by using square roots. So, you done? Alright, so, we take a look at the process of this. We first need to know, when am I going to solve quadratic equations by square roots? When am I allowed to do it? When can I do it? And I'm going to tell you when you can do it. Use this method when there is no x value. So, use this method when there is no x value. Now, look at all of these examples here. Do you see any x values? Is there an x term? No, there's x squared. That's not x. That's x squared.
What's the X value?
Like 3x. Is there a 3x on any of these, or is anything x? No. There's no x terms. Standard form. Alright? So, Amber Alert. Standard form involves an x value, right? Well, there is no x value on these. So these are problems where we could use square roots to solve it. Here's how you do it. First of all, we need our quadratic equations to be in this form. X squared equals n. So you got your x squared on the left, and you've got some number on the right. Notice that that number does not have an x value. Alright, now, this can be solved using the square root property, which says that if x squared equals n, then x equals the square root of n. I just took the square root of both sides. Now, technically, I should put plus minus here, I guess. Alright, so the first step to solving is to isolate the x squared. That is, get the x squared by itself. The second thing is to just simply take the square root of both sides. And the third thing is to simplify the radical, just like we just talked about, placing a plus minus to indicate both answers. Alright, so in number 1, it says use this method when there is no x value.
Okay, so
Alright, so,
add the 64.
yes, add 64 to both sides. X squared equals 64. Alright, now, once I've got the x squared by itself, take the square root of both sides.
So x equals the square root of 8.
So, plus minus, not the square root of 8, I'm glad you said that. It's just 8. When you take the square root of a perfect square, the square root symbol goes away, guys. This is the same, probably the most common mistake that students make when they're dealing with square roots. They want to keep the square root symbol as part of their answer when it should not be there.
So then, should we take the square root off the example?
No, because we don't know what this n is. This n could be 5. Can you simplify square root of 5? No, so if you can't simplify it, you leave it. Huh? Okay. Let's look at number 2. Now, first step is to try to get the x squared by itself, right? So, minus 8. 7x squared equals 7. Now what? Divide both sides by 7. X squared equals 1. Now take the square root of both sides. So x equals plus minus 1. Alright, I'm going to pause the video and let you do number 3. Alright, so we're going to subtract 5 from each side. So 81x squared equals 16. Now divide both sides by 81. So x squared equals 16 over 81. Now, here's a fraction. It would not reduce, normally, you can't reduce 16 over 81, but I can take the square root of it. Plus minus 4 over 9. Leave your answer as a fraction. Do not convert this to a decimal. Alright, let's do number 4.
I got .197.
I'm so glad you said that you got a decimal, because we don't want any decimals. No decimals. So here's what we're going to do. Good. I'm glad you like to do the opposite of what I say. Alright. 8x squared equals 16. Divide both sides by 8. X squared equals 2. So we're going to take the square root of both sides. X equals plus minus root 2. No decimals. Alright, you try number 5. Three on video here.
I don't get number 9.
Okay, well, let's do it. So we're going to subtract 4 from each side. Negative 3x squared equals negative 81. Keep solving. Divide both sides by negative 3. So x squared equals positive 27. So you're going to take the square root of both sides. 3 and 9 will be the factors that you would use. And what's the square root of 9? 3. So 3 on the root of 3. So, again, you break the 27 down into 9 times 3. The square root of 9 is 3. So mark out your 9 and put a 3 on top. And then your final answer is 3 root 3. Okay, number 8, subtract 10 from each side. 5x squared equals 300. Divide by 5. X squared equals 60. Square root of both sides. Plus minus. So yes, you're going to use 4 and 15. Square root of 4 is 2. 2 on the root of 15. And some people might say, well, wait a second, what about 15? It seems like it should have a perfect square factor. It doesn't. Okay, it's not a perfect square and it doesn't have a perfect square factor.
So it'd be 4.
No. It's 2 root 15. You use the 4 as your perfect square factor. Yeah.
That's what I did.
Okay, good. Alright, number 9. We're going to subtract 1. Negative 1/2 x squared equals negative 40. Now, what's the fastest way to get rid of a fraction when I'm solving an equation? Multiply by the reciprocal. So, what is the reciprocal of negative 1 over 2? Negative 2 over 1. So I'm going to multiply by negative 2 on both sides. Alright, so negative 2 and negative 2 cancel. That leaves x squared equals to 80. Now I take the square root of both sides. X equals plus minus. Alright, now look. 80 can be broken down into 16 times 5, right?
4 and 5.
4 and 20 does work, but is for the largest perfect square factor of 80. No, 16 is.
4 the root of 5.
So 4 on the root of 5. Now, the more that you do these problems and deal with these roots, the more you're going to see certain roots come up a lot, like the root of 12, the root of 80, the root of 48, the root of 60, the root of 27. These are common numbers that we take roots of. So, the better you get at these, the more you do them, the more some of these common roots are going to be in your head and you won't really have to do much scratch work because you'll know what the factors are. Alright, I'm going to stop the video here.